Today's lesson is Unit 3, Lesson 1 for Math 1. There are two videos from last semester that you can go look at if you need this lesson kind of slowed down a little bit. Foundations of Algebra, Unit 6, Lessons 2 and 3 also cover the same material. So let's just read through our bullet points. A scatter plot displays two sets of data on the same graph. One set of data is represented on the x-axis while the other is represented on the y-axis. So you're plotting your points. Two sets of data are said to be correlated if there is a dependence between the two variables, like how tall I am, depending on how old I am. There would be a correlation there. But if I took a poll of what color my eyes were and tried to relate that to how tall I am, there would be no dependence between those two variables. A correlation can be positive or negative, or there can also be no correlation at all. So an example of a positive correlation is 2 hours studied and then your test score that you would receive. An example of a negative correlation would be hours exercised. So if the more I exercise, then the lower my weight will be, or we hope. So that's negative. And then no correlation would be comparing your shoe size to how smart they are. All right, there would be no relation with those at all. So a correlation is assessed using the correlation coefficient, which we're going to learn how to do in the calculator. And this is represented with the letter R. So I'm just going to mark off here on my line. It only goes from -1 to +1. And so this is positive right here. And you can look at the graph underneath it. This is a strong positive on the right. On the left, I have a strong negative, and in the middle, I have no correlation whatsoever. Now, if I had a correlation that was maybe somewhere in there, we would still consider that to be like a moderate positive. It's not super strong, but it's somewhere in the middle. Okay, it's better than no correlation at all. So this would be moderate. Moderate, positive, and here in the middle, I would have a moderate, negative. If I'm anywhere around the 0, I would call this weak. Okay, unless it's exactly 0. So that's my weak area. All right. Now that we've looked at some vocabulary, let's dive in with an example. The table shows the dollar value in millions for the sales of CDs last year. Make a scatter plot and determine what the relationship exists, if any. So we're going to stop right there, and we're going to go ahead and create our own scatter plot by hand. So 2000 is up around 13 and a little more. Actually, that would be a little higher. 2001 is up 12.9, so it's kind of close. 2002 is 12, and then almost just right above it. 2003 is 11, 233. 2004 is 11. Okay, and oops, that would be higher. And then 2005 is 10, and 520, so almost right there. So what I have done is I have created my scatter plot for my data. And notice that it does not form a nice perfect straight line, but this is definitely a strong negative correlation. And I can determine that just by looking at the picture of the scatter plot. Now, I can't give you the exact R value unless I type this into my calculator. Okay, so let's pause for just a moment on this example. And I want us to come over to the right side of our paper. And there's not a lot of notes to take here because I've already typed them out for you. But this is all about how do I use my calculator to do all the problems that we're going to be doing today. The first and most important thing I think that there is for you to know is how to clear your memory. I recommend clearing your memory in between every single question or set of data that you need to type in. It is the easiest way to just clean everything and then start fresh. Then you're ready to type in your data and turn on your diagnostic. So remember, typing in your data is stat edit. You type them in. Okay, X's go under L1, Y's go under L2. After that, we want to turn on the diagnostic. When you do that, that's what's going to allow for you to get your R value. Okay, so you need this for the R value, which is your correlation coefficient. So we do second 0, and then you can scroll down until you find the phrase diagnostics on. Be careful because right next to it, there's also a button called diagnostics off. All right. And then you just continue to press enter until you see the word done in your calculator. After you've got all that done, then you can find your line of best fit. We should remember still from last semester is stat calc for enter. Now, in order to get to the calc, you have to actually arrow over to the word calc. And then after that, if you want, you could scroll down and hit enter on number 4, or you could just type the number 4, either one. And then you press enter until you get all of your information. Okay. You can view your graph on a table. The reason that you need to know how to do this is because the table is where we go to view our predictions. And then sometimes you might want to look at the picture of the line of best fit. So to do that, we would press y equals and then type in our equation. In order to view the table, you also have to first type the equation into y equals. And so y equals is a physical button that we hit on our calculator. Underneath that, so if I am viewing the table and I need to make a prediction for the 20th year after maybe I've purchased a car and I want to know the value of my car, sometimes I don't want to scroll down 20 places. I might just want to do a shortcut. So you would press the second button, the window button, which is at the top, and then you would physically type in the value that you want to see. And then you type second graph and you open the table back up. And that number will automatically be highlighted and showing for you. And then to view any graph, the easiest way to do that is to just hit zoom 9 and it will put your window showing your data that you're wanting to look at. And then finally, sometimes we want to view the scatter plot and the line of best fit at the same time. And we're going to do this in our next lesson when we find residuals. So I'm giving you that information here. We would need to type the line of best fit into y equals. Then we would hit second y equals, and enter twice, and then zoom, and then the button number 9. If you actually go down and find zoom number 9, what that says is stat. It's for statistics. It'll automatically zoom you into the data that you want to view. So I'm going to pull up my graphing calculator, and we're going to come back over to this side of the paper, and we're going to get the line of best fit and the correlation coefficient. And I guess type of correlation I should have written on this line. It is a negative, but what kind of negative is it? It is a strong negative. Because as I read from left to right, the points are going in a downward direction. Remember, we read a graph just like we read a book from left to right to see what it's doing. Alrighty, so let me get my calculator up here. So now I've got my calculator, and what we're going to do when we start a new problem is to erase the memory. So to do that, we're going to hit the blue second button. Then it'll be plus 7, 1, and 2. And so now my RAM is cleared and I'm ready to start this problem. Now, because this problem has years, 2000, 2001, 2002, whenever we are doing a problem like this that has years in the X value spot, we don't type in the actual year. So this is the X. What we use is the very first year that they give us, we type in 0, and then 1, 2, 3, 4, and 5. And if the next year on my table, let's say it's 2009, I wouldn't put a 6 for that. I would say, how many years has it been since 2000? And the answer would be 9. So I would put a 9 for that point. So just be aware of the fact that the years might not go in numerical order. All right. And then X's go in L1. In L1, my Y values will go in L2 over there on the calculator in just a second. So let's go ahead. In order to type these into the calculator, we need to go to Stat and then Enter to edit. And my table is cleared and ready to start typing my X values. So 0, enter, 1, enter, 2, enter. So you have to hit enter after each of the numbers. I'm not going to type in the 9. That was a made up year that I just put in there to determine what the value is that I would type in there, just to show you an example. Now let's go over to L2 and type in our sales. Notice that year 0 is the first X value and 13,215 is the first Y value. In the table, those have to be side by side with each other. And also, I'm not going to type in the comma. And then, so 13215 and hit enter. I'd like for you to go ahead, pause the video for a second, and then you finish typing in all the Y values into your L2 column. Now that we have all of our Y values entered, what we're ready to do is turn on the diagnostic. Remember, the diagnostic is what allows me to view the correlation coefficient R. So second, 0. And from here, a shortcut is to hit this matrix button. If you can see it, notice that it has a green letter D right there. So if I click that button, it takes me directly down to the D's in the catalog, and it just helps me to get to where I need to go faster. So just scrolling down, notice I see diagnostic off. I need to keep going until I find diagnostic on. I want to turn it on. And now I'm going to hit enter twice until I see the word done. After I've entered my data and turned on my diagnostic, I'm ready to get the line of best fit and correlation coefficient values. So I'm going to go back to Stat, key over to Calc. Option number 4 is linear regression, so just hit 4. And I'm going to hit enter till I get to calculate, and that'll be my last time to hit enter. And now I have all the information that I need. All right, so our linear regression equation is the first thing that they want me to write down. In order to write the linear regression equation, notice I have y equals ax plus b up here. So the a value goes in for the slope, the b value goes in for the y-intercept. So they use ax plus b, but it still means mx plus b. It doesn't change the meaning of anything. And so the equation I have is y equals negative 533.49x, I'm going to round to 2 decimal places, plus 13,228.38. The reason I chose to round to 2 decimal places is because we're talking about money. All right, so that's my equation. Now, which one is the correlation coefficient? The correlation coefficient is always the bottom R value. It is the R that's all by itself. Notice the one up above it has a square. We do not need that information until we get to a later math class. So for now, I'm going to put negative 9.7. I'm going to round that 6 up to a 7. And so I can definitely see that I have a very strong correlation coefficient. All right, it's a very strong negative. 9.67 I'm sorry, whoops, I put my decimal in the wrong place. That should be a 0.9 and then round the 6 to a 7. There we go. This was 49, this was 13, 33. Okay. Now that I have gotten all the information from my calculator, I really didn't do much in the way of mathematics yet. I just had to learn how to operate my calculator. Now I'm ready to come down and answer this question. And this question right here is the whole reason that we need to know how to get the linear regression equation, because we're going to make a prediction. Okay? So, what are the CD sales in the year 2013? Okay, so first thing I'm going to do is I'm going to bring down my linear regression equation. Y equals negative 533.49x plus 13,228.38. And then what are they asking me for? They want to know, what are the CD sales? The sales are the Y values. So what are the sales in the year 2013? 2013. So if I had to type in the year 2013 into the table originally, I would not have typed 2013. Remember up here where we talked about this 2009. So from 2000 until 2013, how many years has it been? And it has been 13 years. And that is my X values in the table up above. So what I'm ready to do now is just type this directly into my calculator. So let's type, I've typed it all in exactly the way that I wrote it, hit enter, and now I have my answer. The answer, what would the sales be in the year 2013? Sales, or the Y values, are going to equal $6,293.01. And that's my final answer. Great job. Here is what you're going to do next. You're going to flip your paper over and you're going to complete the very first practice problem on your own. But before you get started, we're going to use the original years to create our scatter plot. So in year 2000, it is 7.66. So that would be approximately here. These are estimations. We want to get as close as possible, but it won't be exact. Okay, so you're going to plot the years exactly how they are. However, when you go to type them into the table, remember, years are your X values, which go under L1. When you type it in the calculator, you have to do 0, 1, 2, 3, 4, 5, and 6. All right, so go ahead, pause the video, and I want you to completely finish practice problem number 1. All right, so I have completed practice problem number 1, and I came to the answer that Arby's will make 11.42 billions of dollars. Okay, and that's in the year 2013. All righty, let's take a look at example number 2 together. Marcus measured the height in inches and Y of plants over the course of 3 weeks. The correlation coefficient between the number of days X and height of plants is 0.85, which could be concluded based on the correlation coefficient of the data. This is an extremely good example of an EOC style question that is simply evaluating what it is that you understand about correlation coefficient. Okay, so the first thing that I want to point out is that this is a positive increase, okay, because they didn't say negative, so it's positive. So what I notice here are the words increases or decreases. Well, they're not decreasing because the correlation coefficient is positive, okay? So increases is good, decreases is bad. Alrighty. Next, was 0.85, was this strong or was it, let me mark out B and D, was it strong or was it weak? And these are the key words here, weak or strong, okay? 0.85 is pretty strong. We said up above for our last example that our correlation coefficient was moderately strong. It was at a 0.71. So 85 is even stronger than that. So we're going to go with strong for sure. And that's my answer. Let's take a look at number 3. The table below displays the walking heart rate of 8 girls in beats per minute. Using the linear best fit model for the data, what is the predicted running heart rate of a girl whose heart rate is 100 beats per minute? All right, so here's what we're going to do. We are going to first get the line of best fit for the data. That's the first thing that I want you to do. So you will need your calculator, and I'm going to move it over to the left. Okay, we want to re-clear our memory. Second plus 7, 1, 2. And then I would like for you to go to Stat, Edit, and type in your walking heart rate is going to be your X values because that is on the left-hand side of the table, so it will go under L1. These running heart rates will be your Y values and they will go under L2. So go ahead, fill this in, and then write down for me right here, what is the line of best fit for this data? Welcome back. I typed in all of my data in L1 and L2, and now I am going to just quickly review over how did I get my line of best fit that I wrote down right here. I simply went to Stat, over to Calc, number 4, and I hit Enter. Okay, and then this was the answer that I got, 1.04. I rounded to 2 decimal places, and then 58.84. This 4 after that 4 is less than 5, so this 4 stays a 4. Remember how we do our rounding. So this is the equation for my line of best fit, but I'm not quite finished. I still need to make a prediction. So I need to figure out where to plug in some information. The final question says, what is the predicted running heart rate of a girl whose walking heart rate is 100 beats per minute? Well, if I added that 100 beats per minute to my table, it would go under the X column because that was the walking heart rate column. So in my equation, I will need to plug in the 100 where the X value is. And I'm going to do this in my calculator. So I'm just going to type 1.04 parenthesis 100. Whoops. Okay, so that's 104, and now I need to add 58.84. And I get 161. All right, so I retyped in my line of best fit with the 100 plugged in, and I had made a mistake the first time I typed it. Right here, when I added, I just typed the wrong number. I typed 57 instead of 58, and that's why my answer wasn't quite right. So be really careful to double check what you're typing into the calculator because it can lead to some mistakes. So this time I typed it correctly. 1.04 times 100 plus 58.84. And the answer that I got was y equals 162.84. And that rounds up to 163 beats per minute. Very good. What I would like for you to do now is to pause the video, and I would like for you to read through and think about problem number 4. All right, so I've given you just a minute to read through this and to think about how you might determine an answer. And so I just want to read through this and then highlight some important information. A statistician collected the following data to explore the relationship between two variables, X and Y. They're not really explaining what these variables represent or what the numbers mean, and that's okay. The statistician performed a linear regression and also plotted the residuals. Based on the scatter plot, so that's important, based on the scatter plot, and she also did linear regression, okay? She decided to exclude one data point. She performed linear regression on the set of remaining data points. The result was that of a new linear model that fit the remaining data more closely than the original model fit the data. Which data point did the statistician exclude? So my key things here that I see are scatter plot and linear regression. I'm going to teach you how to do a scatter plot in your calculator. If you look on the back side of your paper, the steps for doing that are on the right-hand side here at the bottom. How do we view the scatter plot and the graph of the linear best fit model? First, we have to type the line of best fit into y equals. So before I can type it into y equals, I need to know what it is. And then I'm going to refer to the second set of steps after I type in my line of best fit. So let's come over here and just type in all of this data into stat edit. Go ahead and type all that data in there. Now that your data is all typed in, and if you need another minute, please just pause the video. This is how yours should look after you've typed it in. I am going to use the calculator to get the line of best fit. So stat, over to calc, option 4. Some of you also like to go down to 4 and hit enter. That's all right too. Go to calculate and press enter. So this is my line of best fit, and I'm going to write it down on my paper so that I don't forget it. So let's say 2.63 x plus 5.38. That's my line of best fit. So what I'm going to do now is I'm going to go into y equals. And I want to point out that I wrote the equation down on my paper because once I go back, my line of best fit has disappeared and I would have to follow those steps again. So write it on your paper so that you don't forget what it is. And now I'm going to type the y equals is already there. So 2.63. The X button, in case we hadn't, nobody's asked that question yet, is right here next to the green alpha button. So use that X button. And then plus 5.38. And you can hit enter if you want to, and it'll go down to Y2. We don't need to type anything into Y2. All right. Now what we're going to do is we're going to turn on the scatter plot. So we're going to do this by hitting the blue second button and then Y equals. And notice this is stat plot and it's currently off. So I'm going to hit enter and enter again to make the word on be highlighted. After I do that, I am going to hit zoom and number 9. Zoom number 9, if we scroll down and look at what it says zoom stat. We're working under the stat button, so any information typed in here will be highlighted with the zoom stat button. So that's 9. And there it is. What I am able to look at here is all those little dots, those are the scatter plot that your calculator just plotted for you. And they're a whole lot more accurate than it would be if, like in examples, the first two that we did, where we had to create our own scatter plot, this is going to be exactly accurate. And so we also graphed the line of best fit. And the reason that we did this is because we wanted to see which data point was an outlier. Which one did the statistician remove because it didn't fit the data like most of it did? And the answer is this one right here. But how do we figure out what that point is? So here's what we're going to hit. We're going to hit trace, this button right here, and notice that that has now been highlighted. If you click the right arrow, it'll go to the next point, and the next point, and the next point, and finally it's on the point that we want to exclude. And that point is 8.2 and 24.3. So that is D right here. D matches the point that is currently highlighted on my calculator. And that was great. We did it 100% in our calculator. Alrighty, let's go look at example number 5. And I do encourage you at any point in time, if you feel like I went too fast, if you need to rewind the video and just kind of watch it after you've finished writing everything down, that you can do that. You can copy the notes and then go back and just rewatch it. And you can also do that trying to follow along with your calculator to learn these steps as well. Learning a graphing calculator is a lot like learning a new tablet or cell phone. Say you are an Android user and you switch to Apple. It takes you a little while to figure out how to make this new device work as easily for you as your old one did. And that's the exact same process that we have to go through with our TI-84 calculators. Alrighty, I am ready to go look at example 5. The table below shows the U.S. average life expectancy at birth in years, in various decades. What is the meaning of the slope of the linear best fit equation for the data? So the first thing that I want to do, since they're asking me what is the meaning of the slope, I want to get the line of best fit and I want to find what does the slope equal. So you're going to pause your video and I want you to practice. Let's clear our memory. Second plus 7, 1, 2. I want you to go to Stat and I want you to type in all of your data and pause the video while you do that. Welcome back. I have finished typing in all of my data. It is always important that I just go through and make sure I didn't make a mistake with my typing. One number can make a huge difference when solving a problem. I also want to point out that years since 1983, the 70, and then over here in the Y value, it did say 77.0, but I didn't bother to put the 0.0. You could have if you wanted to. But what I'm ready to do now is to find the line of best fit. So stat calc 4, enter. And so my line of best fit is y equals 0.2 x plus 62.7. I rounded. Okay. So I am done with my calculator. So let me get this out of the way. And now we're going to look at these answer choices. So what is the meaning of the slope? The meaning of the slope. Well, my slope is 0.2. So think about what that means for just a minute. The predicted average life expectancy at birth in 1930 was about 62.7. If I plug in 1930, that would be one up from here. That would require that I type in a 0. Because that would be years since 1930. In 1930, it equals year 0. And if I type in a 0 right here, 0 times 0.2 is 0. And then I would add 62.7. And so the answer would be 62.7. So the predicted average life expectancy at birth was 62.7. That looks right to me. Look at B. The predicted average life expectancy at birth was about 57.6. Is that true? And the answer is no, that's not true because we just found that it was 62.7. The average life expectancy at birth increases by 6.7 each year. And that is not correct either. 6.7 isn't anywhere in any of our values. And then the average life expectancy at birth increases by about 0.2 each year. And that statement is also true. So we ended up with 2 correct answers for this equation. All right. So sometimes in our notes we get more than one correct answer, okay? So A and D were both correct. One of them was just simply, okay, let me take that back. We found 2 true statements. A and D are both true statements, but let me go back and reread the question. That's very important. What is the meaning of the slope? The slope. It increases by about 0.2 each year. D is the only one talking about the slope. All right. A was asking me about a prediction. So if they had said which of the following is an accurate prediction for this data, then we would have chosen A. All right. So be very careful about that. They might give you 2 pieces of information that are true. All right. So we are done with number 5. Number 6. Alyssa enrolled in a public speaking class. Each week she's required to give a speech of greater length than the speech that she gave before. The table below shows the lengths of several of her speeches. If the trend continues, in which week will she give a 12-minute speech? So what I'm going to do is I'm going to identify a possible misconception for this problem, and then I'm going to ask that you pause the video so that we can give you a chance to try this on your own, okay? So if this trend continues, in which week will she give a 12-minute speech? So I want you to pay attention to seconds and minutes. So you're going to find the line of best fit first using your calculator. Then you're going to do something here, and then you're going to plug that in here and make a prediction. So those are my tips and hints for you. And I'm going to give you just a few minutes, pause this video, and I want you to try this completely on your own. We are, right here is where I kind of stopped for us. So the trick that we had to figure out was that the length of the speech in the table is in seconds, but they asked me how long or in which week would she give a 12-minute speech. So I needed to convert minutes to seconds. And if I plugged that in the table, I would know that I have 720 seconds. Now I have to answer the question, what is the X value? So I found my line of best fit, y equals 30x plus 60. And then you can see that right here in blue, I plugged in the 720 seconds for the length of the speech. I did that because X is the week number and Y is the length of the speech. So that's where it had to go in. And now I'm ready to solve this equation. Subtracting 60 from both sides. And then what I'll do is divide by 30. And so I get an answer of 22, which I do see is option A. Option A. So week 22 is what that means. Okay. We are almost finished. We have 2 more to do. Denisha bought a car for $15,000 and its value depreciated linearly. So the very hardest part about this is realizing that you were just given an ordered pair. Denisha bought a car for $15,000. But how long had she owned that car when she bought it? She had owned it for 0 years, comma, $15,000. That's the ordered pair that they just gave me. Then they're going to give me another ordered pair. After 3 years, the value was $11,250. What is the amount of yearly depreciation? So there's really one of 2 ways that you can solve this. We did problems like this in our last unit where I gave you 2 ordered pairs and then you wrote the equation of the line for me. And they are asking about yearly depreciation, which is just another word for the slope. They just want to know the slope. So you could use the slope formula if you wanted to, or you can use what I'm teaching you right now about how to use your calculator. In your calculator, what you would do is you could create a value, right? So type, there shouldn't be an L there. Okay. Type X and Y's into stat and then find the line of best fit. So you can still do this the old way if you want to. I'm going to show us how to do it the new way, okay? If you have a calculator for a problem like this, then it wouldn't matter which method that you chose to do. My X values were 0 and 3, and then my Y values are 15,000 and 11,250. Okay, so in my calculator, what I'm going to do is clear my memory. Second plus 712. I'm going to go to Stat, Edit, 0, Enter, 3, Enter. Table over to L2, type in the 15,000, enter, type in the 11,250, hit enter, hit stat, over to calc, 4, enter a bunch of times, and then I get that my, well, let's see what number here. My slope is, that they gave me, is the A value, negative 1,250. So what's the amount of yearly depreciation? Well, their word depreciation is already accounting for the fact that it's negative. So we just need to choose the number that matches, and that is C. Okay, awesome. What I would like for you to do is to practice that same method with number 8. But there is a key thing to remember here, and this is the thing that the majority of my students forget. Okay, so what we're going to do is we're going to create a table from the 2 ordered pairs that they give us. In 1977, a calculator, a graphing or scientific calculator, cost $175. In 2004, so they're giving me enough information for a table, the price was $15. All right, so that's X's and that's Y's. Assuming that the change in the price was linear, what was the approximate price of the calculator in 1998, which would go somewhere here in the middle? So, what are we going to type in our calculator? Again, we do not ever type in years. So what I would do is for year, the starting year, that is always year 0. Okay. Now for the 2004, I would do what is 2004 minus 1977. And then the answer to that is 27. 27. So in my calculator, I would type 0 and 27 in the X or L1 column. All right. So go ahead, type this in Y equals and pause the video and come back in just a minute. And I want you to make sure that your line of best fit matches mine. So that's my line of best fit that I have gotten. Now I am almost done, but I need to use this line of best fit to now make a prediction. And it's all going to come right back to what do we type in for X here? Remember, we did 0 and then we did 27. So what number are we going to plug in for 1998? And so we're still going to do that same process. 1998 minus 1977 is going to give me 21. So I'm going to plug a 21 into here. And then I'm going to type this exact thing into my calculator. And it will tell me that Y equals $51.10. And so which of these answer choices was the closest because they used the word approximate? And that is answer choice C. All right, so that's the end of our lesson. But there is a lot to learn in our calculator. So this is going to require a significant amount of practice. Now, I do want to demonstrate for you that you can get the Wabbit EMU app. So I just very quickly wanted to demonstrate for you how we can, if you have an Android device, if you have an Apple device, it doesn't work, but we can very easily just go to the Play Store. Okay, go to the Play Store and type in Wabbit EMU, and it is spelled WABBITEMU. If you can see that, okay, Wabbit EMU. And then just search for that. With Android devices, it's a complete free download. You don't have to pay for anything. I believe Apple still charges. It's maybe $10. It's a whole lot cheaper than buying the actual calculator, but a huge benefit with your Android device is that you get to download the exact same calculator that we use in the classroom. And I just want to show you real quick what that looks like. If on my phone, I keep the Wabbit EMU device here so that I can access it anytime. All right. And so when I pull this up, and let me just clear, I've hit some buttons. This calculator looks identical to this calculator. It just happens to now be the size of my phone. And they both operate exactly the same way. Okay, so some students still really struggle. Now mine is already on here, but when you first open up the app, it will ask you, let's see, you will see this when you first open the app. What you want to hit is say, help me create a ROM. So help creating a ROM, and then hit next, and then you're going to choose the calculator that you want. Now they did not all work for me on the same first try. So I stuck with the 84, and I just tried every single one of the 84s until I got one to work. For me, the one that's working right now is the one on the very bottom. Okay, so once I clicked on that, and then I hit next over here, Then it just automatically did whatever it was going to do. And in a minute, it just opens it up for me. And then I get to see and use my calculator the same way that I would in class. Okay. So you just need to be a little patient with this. Sometimes it takes a few tries to figure out which of the calculators will work best on your phone. And when it's ready, it just pops right up. You're already starting with a clear memory. So I'm going to hit just clear, and then it's ready to go like any other calculator. Okay. All right. Hope this helps. We definitely need to do some extra practice at home. So if you can get this as a tool, it is definitely a help to you. All right. Until next time.